Have you noticed how much brighter, faster and therefore safer car lights are these days? Well, that's because they now use LEDs, solid-state lighting made using vacuum processes. Solid-state lighting is a type of lighting that uses light-emitting diodes as sources of illumination rather than electrical filaments used in traditional light bulbs. Solid state in an LED is emitted from a solid object, a block of semiconductors. Solid state lighting creates light with substantially reduced heat, reduced energy consumption and significantly increased lifespan. LEDs can be 10 times more efficient than incandescent bulbs. Significant power savings can be achieved from this technology, and expectations are that up to half of all general lighting will be SSL by 2015. Currently, 20% of all electricity generated globally is used in lighting. 20% of the world's power used would become only 2%, and vitally generating significantly less CO2 with no loss of lighting power. Another major growth area is backlighting of flat panel screens in TVs, laptops and notebooks. LEDs use less power and therefore batteries last longer. The chemical vapour deposition manufacturing processes for LEDs are all vacuum-based, and cost-effective vacuum solutions help drive down overall production costs, which are now very close to traditional lighting.
Discussions with an original equipment manufacturer in the LED market identified a need for enhanced pumping performance for a new generation of LED process tool. The LED market is currently growing in excess of 50% a year, driving requirements for tools with much higher productivity. Key was optimised pumping performance for the main process gas used in LED production, hydrogen. As the smallest molecule and the lightest gas, it's a real challenge to pump effectively. A further factor was that the pump needed to fit into a limited space on board the process tool. So, we identified the possibility of combining core modules from our existing pump range in a novel way to achieve their targets. Only 60 days after identifying the specification, a trial system was shipped to the customer for evaluation. This was mainly achieved thanks to the effective use of our pump modelling tool to prove its feasibility. There was rapid prototyping for the new mechanical elements and the use of our in-house hydrogen test facility to prove performance. Using an existing pump platform with common software and defined interfaces enabled subsystems to be combined into a new product with minimum design effort. This rapidly provided the customer with a new and really effective solution.
Not only do we supply pumps into the alternative energy market, but we've concentrated on all our products being more energy efficient and having a lower utilities footprint. We've introduced similar technologies to car manufacturers' efficient dynamic programs, with, for example, pumps automatically going into standby mode. New and even larger manufacturing plants also require abatement solutions that help manage the safety and environmental risks of hazardous materials.
Hazardous gases used in LED manufacture have to be abated, and Edwards technology leads in this area. Into this market we provide two combustion products with a technology which burns the ammonia used in their production without forming NOx, one of the contributors of acid rain. Another innovative and very effective technology uses catalysts similar to those used in cars for reducing NOx emissions. As a result, we now supply many of the leading LED manufacturers in the world who, in turn, supply global manufacturers of a number of consumer products such as car lights, TVs, laptops and so on. We really have the world-leading technology in this sector.